This is the Fairwinds Energy Education Podcast. I'm Kevin Hurley. We're here with Arnie Gundersen again. It's the week of the 28th. Thanks for coming on, Arnie.
Hi, Kevin. Glad I could.
I want to start out talking about one, topic that we're receiving most of our emails on right now, and that's the Hurricane Sandy, and what that means for U.S. nuclear power plants. Should we be running for the hills?
Well, this hurricane is huge. And it's occurring at the full moon, which means that tides are high. But the real issue is likely to be the storm surge, which is essentially the extra height in the center of the hurricane as the water comes in, and the waves. And then, but more importantly, will be the flooding, the inland flooding. The waves and the storm surge will likely do a lot of destruction on the New Jersey coast, but likely not do too much damage to the power plants. My expectation is that it will be flooding related and high wind related.
But these power plants should be ready for that.
The plant can withstand relatively high winds, but the transmission grid can't. That's all those transmission towers that are all over the states. So what's likely to happen is that the power lines will go down and the plant will suffer what we call loss of off-site power. And that's what happened at Fukushima Daiichi. The off-site power was eliminated. At that point, the plant, if it's operating, the plant will automatically scram because it's got no place to send its power.
Now, when you say scram, that means to shut down the reactor?
The control rods are going real quickly, and the nuclear chain reaction will stop. The plant needs to drop its power immediately because there's no wire at the other end to send it anywhere if the offsite power is lost. So what happens next, though, is that the diesel generators have got to turn on because there's no other alternative source of power. Some of these plants have 2 diesels, and some of these plants have 3 diesels, and they're designed so if one of the diesels fails, they can still get by.
You've talked before about loss of off-site power. I guess, can you just explain why off-site power is needed on the nuclear plant?
Yeah, it's hard to imagine, but a nuclear plant needs power to generate power. It's got ancillary systems that have to run off of power. And so as it sends power out to the grid, it also sends some of that power back into itself to run. Almost 5% of the nuclear electricity is used to run the pumps that make the electricity. So when off-site power is lost, the plant is forced to dramatically reduce power real quickly, and then it still needs to be cooled. You'll hear in the next 2 days that we've shut down the plant. We've safely shut down the plant. What that means is they've stopped the chain reaction, but what Fukushima taught us was that doesn't stop the decay heat. There's still as much as 5% of the power from the power plant that doesn't go away when the plant shuts down. And for that, you need the diesels to keep the plant cool.
So if and when the plant loses off-site power, the diesels kick in to keep the plant cool, and those diesels fire up no problem.
Well, when I was at Northeast Utilities back in the 70s, we had a hurricane come in, and we lost off-site power. The plant scrammed, and we had 2 alternative ways of producing power, and one of them didn't work. So we were down to 1 diesel, and we sat for 6 hours and on just 1 diesel until the off-site power was restored and we could get power into the plant to help with the cooling. The plant's designed to run on 1, so of course the Nuclear Regulatory Commission would say everything was safe and sound, but I'll tell you, as the plant operator, as the people running the plant, it's a little bit of a nervous time to realize that you're on your last fallback. it's you just hope that the last fallback keeps running.
What should plant operators and managers in these companies be doing in preparation for Hurricane Sandy?
It would be better if the plants shut down before they lost the offsite power. As the hurricane comes in, they'll know that pretty soon there's going to be high winds, and while the plant itself may withstand the high winds, the transmission won't. So it would be better if the operators, instead of waiting for the power to fail, shut the power plant down ahead of time. And the reason for that is that when a plant scrams, that's a sudden shutdown, that's a pretty severe jolt to the systems, and it's a challenge to the safety systems. Whereas if the operators can bring it down slowly over 5, 6, 7 hours ahead of time, that's less of a challenge. Sort of the difference between slamming on the brakes and coming to a gradual halt. It's less stressful for the power plants. So I'm hoping that there's 26 power plants in the East Coast that are in the area where Sandy is likely to hit. And hopefully as the storm track becomes better defined, the plants that are most subject to it, likely New Jersey and Pennsylvania, preventatively shut down, and that would, of course, minimize the impact, the jarring to the nuclear reactor and its safety systems.
So in the event of a loss of offsite power, we're talking about the diesels, and it's quite possible they'll be down to relying on their last diesel to keep the plant cool, and that keeps the reactor cool. From Fukushima, though, we know that the fuel pool needs to stay cool as well. How do the fuel pools factor into this?
The nuclear reactors are not designed to cool the fuel pool off the diesels. And the theory has been that, well, pretty quickly we'll get power back and we'll be able to cool the nuclear fuel. So the reason they didn't cool the fuel pool with the diesels is because those pumps require a lot of power, and you need bigger diesels. So no one wanted to buy bigger diesels, so they basically have penciled the problem away and said that, well, we don't need those diesels for 6, 8, 10 hours, so therefore we'll figure out a way of cooling the fuel pool even though we've lost offsite power. There's a problem there. There's a lot of problems there, as we learned at Fukushima. The fuel pools, especially this time of year, some of these plants are recently refueled, and they have hot fuel in their fuel pools. The fuel pool churns off an enormous amount of moisture, even in the best of circumstances. And as it gets hot, if the diesels fail and the pumps aren't on, the water will heat up several degrees an hour and start throwing off more and more and more moisture. Well, the buildings are not designed to handle high humidity. So in addition to the fact that the fuel pool is warming up, you're throwing an enormous amount of humidity up into the air as well. And the last thing is this was a study done by Dave Lockmont back in the 90s. He discovered that the fuel pool liner seams are not really designed to approach boiling water. And in fact, the stainless steel liners in the fuel pool may unzip if the water gets too hot. So there's a lot of problems with allowing a fuel pool to overheat. And yet we've deliberately built our nuclear plants so that the only fallback in the event the diesels turn on is to let the fuel pools begin to get warmer.
And how long would it take for a fuel pool to boil?
Well, depends on how much fuel is in the pool. All these pools are full, but more importantly, some of those reactors, those 26, have recently refueled, so they have hot nuclear fuel in the fuel pools. And in that case, that's a couple of days.
Mm-hmm. So, Arnie, Hurricane Sandy, what's the bottom line? What should people be thinking?
Well, it's a big storm, and it is likely that there'll be loss of offsite power for quite a few of these 26 nuclear plants that are involved. And that means the diesels hopefully will all turn on, and at least one of them really must turn on in order to safely get through this. The chances of a diesel failing are less than 1 in 100. So if you have 2 diesels, it's 1 in 100 times 1 in 100, or 1 in 10,000 possibility of both diesels failing. That's not remote, but it's not I got to head for the hills today kind of a problem. We need to keep track of what plants are experiencing loss of offsite power, and hopefully management and the NRC is forcing these plants to preventatively shut down ahead of it. It's just less stressful on the power plant.
Arnie, thanks for that update on the hurricane. Now, a quick change of topic. I know you received quite a few emails last week, people concerned that there may be a fuel pool fire in Unit 4. Can you tell me just a bit about that?
Yeah, we were inundated by phone calls from as far away as Peru and emails from all around the world about what turned out to be a hoax. Someone on the internet misinterpreted a bunch of data. And then other people on the internet started to take old Reuters stories from 1.5 years ago and change the date and put these Reuters stories up. But it was a hoax, and Fairwinds was. We were constantly talking to reporters and people who called in, as well as trying to respond to some of the emails. This is a case where the internet, well, it's wonderful for access, provided just awful data.
You and I were talking right before the podcast, and you expressed that you thought that this hoax drew attention away from a bigger piece of news coming out of Japan right now.
You know, there really was an important story coming out of Japan this week, and that was this report from Woods Hole Oceanographic Institute that talked about how much radiation is in the Pacific, and how it's not decreasing as they might have thought it would. There's a world-class organization based on Cape Cod called Woods Hole, and they study the ocean. They just came back from the coast of Japan, and they found that the benthic organisms at the bottom of the ocean, benthic means the bottom-dwelling organisms at on the ocean floor, are not seeing a decline in the amount of radiation that they're carrying. Now, they were very surprised. They had thought that the Fukushima accident occurred 1.5 years ago, and they could go back now and they begin to see a decline. So the message is that the fish in the Pacific near Japan are still contaminated, especially the ones that feed on the bottom of the water. But the other message is that the Woods Hole was surprised that it's not going down. Now, they reached the conclusion the reason it's not going down is because Fukushima Daiichi is still leaking into the ocean. So that even though the blast into the atmosphere essentially was, 95% of it was done by April of 2011, the end of April 2011, that we're still seeing the plant leaking into the ocean. Now, Tokyo Electric is building a wall along the coast. It's going to be 100 feet deep. It's not an up wall, it's a down wall to prevent leakage into the ocean. But they're not going to be done until 2014. We talked on the other podcast about the fact that the fuel pool is not going to be done until 2015. So Tokyo Electric has quite a few problems, and they can't spend enough money on any of them to get them solved in a quick way. So Woods Hole has come out and said that this is certainly the worst release of radioactive material into the oceans ever in the history of nuclear power, and that it's not stopping. It's going to continue until these plants get rid of all the water that's in their basements.
And at this point, the damage is done.
And will continue to ooze radiation into the water. The Tokyo Electric now is. Where is this coming from? It's probably a good question to ask. Where is this radiation coming from? It's the nuclear cores are are melted down, and they have to be cooled. So you're pouring water across radioactive uranium and all of its daughter products. That water then is leaking into the basements of all the buildings on site. They're sucking that water back out of those basements and pumping it back in to cool the reactor again. But in the meantime, they have a giant filter on it, sort of like the Brita filter on your sink, but huge, that's trying to absorb some of this radiation. Those filters get so hot that they have to be put into a football field-sized place on the Fukushima site. They're running out of room to store the water. Within a year or two, there won't be any more room to store the water on site. This problem is not going to go away tomorrow, and it's not going to go away even this year or next year. Likely, water management is the single biggest problem with Fukushima Daiichi. And assuming there's no earthquake, the biggest problem that Tokyo Electric is going to be facing is water management. The water continues to come in from the groundwater into these basements, continues to get highly contaminated, continues to leak out into the ocean, and the filters they're trying to capture it on become so radioactive that they have to move them out to a football field on site, and that football field is rapidly becoming full. So what to do in the long term with all of this radioactive water is the biggest problem that Tokyo Electric has to face, assuming there's no earthquake that knocks down Unit 4.